Kirsten Pelz-Stelinski. I'm an entomologist at the University of Florida at the Citrus Research and Education Center, and today I spoke at the Grower Day presentation of the research that was done at the International Research Conference on Huanglong Bing, and I talked about some of the discoveries that have been made and progress that has been made towards developing long-term solutions for Huanglong Bing. And so there were a few general areas that I talked about. We heard a lot of new information about psyllid biology and psyllid transmission at the Huanglong Bing meeting. One of the things that we heard about quite a bit was the improved understanding of how psyllids transmit Liberibacter. So we heard from Susan Halbert and other groups that psyllids actually are capable of inoculating plant flesh, and that the females that inoculate plant flesh, when they lay eggs, those eggs then will develop into nymphs that can quickly acquire Liberibacter that multiplies rapidly within the flesh. So this is a little bit of a paradigm shift. The plants actually don't need to develop a systemic, symptomatic infection before psyllids are actually able to acquire. Psyllids can acquire right away from that oviposition site. So that was important and really highlighted the importance of nymph control. And then we also heard quite a bit about new solutions for developing resistant plants, so cultivating plants through the use of new rootstocks and genes that confer resistance in citrus plants that will be more amenable to withstanding infections of HLB. We also heard about the development of a technology called RNAi. So basically, we can use something called double-stranded RNA to specifically target genes in either the psyllid or in Liberibacter itself to activate the RNAi system, which is a defense system in cells that will basically silence the genes of interest. So we heard a lot about some potential genes that have been shown to be very good active targets for double-stranded RNA that can be applied and reduce either psyllid lifespans. So application of these double-stranded RNAs can induce psyllid mortality, and in some cases they can reduce the effects of Liberibacter in plants. So that's a really promising tool that's on the horizon for application in citrus. And then we also heard a little bit about some progress that's being made to interfere with psyllids' capability to transmit Liberibacter in the development of psyllids that actually cannot transmit Liberibacter. So we heard about the new psyllid project, which is a project that's really focusing on using native viruses of psyllids or native bacteria of psyllids to use them as these viruses or bacteria as vehicles for introducing either genes that would activate the psyllid immune system to resist Liberibacter or interfere with Liberibacter transmission in some way. So I think that the take-home message from at least my talk was that we have a lot of really great, promising solutions on the horizon that are under development, and we look forward to hearing more progress 2 years from now and how those have developed.